Today's physics and clip is from the movie Too Fast, Too Furious. In the scene, our protagonist, Brian O'Connor, needs to catch up with a boat which is holding his girl hostage. Being the smart guy he is, O'Connor gets that brilliant idea to drive his car off a ramp and into the back of a yacht. Our question of the day is this scene possible?
Let's start with the velocities. We see the speedometer a couple times in the scene. The initial velocity that we see the car moving at is 38.4 meters per second. 6 seconds later, we see the speedometer again, and the velocity is 52.3 meters per second. To find the acceleration of the car, we just need to take the second velocity, subtract the initial velocity, and then divide the whole thing by the time. This means that the acceleration is equal to 52.3 minus 38.4 divided by 6. This leaves us with an acceleration of 2.32 meters per second squared. Assuming that the acceleration stays the same, we are able to find the velocity right before it leaves the ramp. Since the time between the moment we see the second velocity and the moment we see the car leave the ramp is 3 seconds, and acceleration is equal to the velocity final minus the second velocity divided by the time between velocities, we can find the final velocity. Substituting the values we received into this equation, we get 2.32 meters per second squared equals the final velocity minus 52.3 meters per second divided by 3. This leaves us with a final velocity of 59.25 meters per second.
Next, we need to find the time the car is in the air. Using an online protractor, we can tell that the angle of the ramp is 11 degrees. To find the time the car is in the air, we use the equation velocity final times the distance it travels up is equal to the velocity initial times the distance it travels up plus the acceleration due to gravity times the time it is in the air. Let's fill in some numbers. We can knock out one side of the equation because once the car reaches its max height, its velocity upwards becomes 0. So the whole left side of the equation becomes 0. We found that the initial velocity is 59.25 meters per second, and we input y as sine of 11. The acceleration due to gravity is negative 9.8 meters per second squared, multiplied by the time. Solving this equation, we find that the time to get to the halfway point in the air is 1.154 seconds. We multiply this time by 2 to find the total time the car is in the air, which is 2.308 seconds.
With all the information we just found,
we can find the actual distance the car jumped. Because some of the velocity is converted into an upward motion because of the ramp, we need to find the x-component of the velocity. To find the x-component of the velocity, you take the initial velocity and multiply it by the cosine of the angle of that ramp. That means the x-component of the velocity equals 59.25 multiplied by the cosine of 11, which is 58.16 meters per second. From there, you can find the distance the car traveled using the equation distance equals velocity multiplied by time. Because the car was in the air for 2.308 seconds, and the velocity is 58.16 meters per second, ignoring air resistance, the distance would be 134.23 meters. This distance is completely different from the distance between the boat and the ramp in the movie. We found the distance in the movie by using the length of the Camaro. The Camaro is 4.84 meters long, and the distance between the boat and the car is 5 Camaros. This gives us a total distance of 24.2 meters. The theoretical distances and the actual distance is 110.03 meters off, which is a huge margin of error. Even if we did factor in air resistance, it wouldn't have resisted 110.03 meters of motion.
Overall, while this scene from Too Fast, Too Furious may look cool, the physics is completely wrong, as the car and smart guy Brian O'Connor should have sailed straight over the boat and landed in the water. Never lucky. Thank you for watching.